Okay, right, 254. So again, I'm sure you've read this, and really, the again, I'll focus on the numbers, but in terms of reading the theory, they're talking about spreadsheets and that sort of thing. And then, so let's get through the first question. Um, get through that. So which two of the following statements regarding spreadsheets in budgeting, if you like, are correct? So let's just sort of get my notes there right. Yes. So it's saying that spreadsheets enable managers. Let's just see all the answers there. Spreadsheets enable managers to consider many different budget options and to carry out sensitivity analysis on the budget figures. Yes, that's true. I mean, you can, if you like, I don't know if you've done all this goal-seeking sort of stuff and using if statements. And spreadsheets are an amazing tool, and being able to, of course, write out all the different activities at which products are being made. You have that happening with spreadsheets. And then minor errors cannot affect the validity of the data. I mean, all you need to do is to have one little error on your spreadsheet, and it can infect and, if you like, render the rest of the data pretty much useless. So that's not true. Spreadsheets are able to take qualitative. Well, no, they're just numerical. Qualitative are almost your non-financial sort of factors. You cannot quite quantify that into that. And the possibility of experimentation is so great that it's possible to lose sight of the ES because you're doing so many things and sometimes you don't know why it is you're doing what it is you're doing. So naturally the answer ends up being B, if you like, question 1. So 1 is B. And so some more theory. In terms of which two of the following statements about manipulation issues involve in revising budgets. So the establishment of ex post budgets is very difficult. Managers who again, so you've put a budget together and now you're working on it and changing it, pretty much is what we're sort of talking about ex post here. Again, if you like, you can get managers. So basically the whole argument is you started a budget and then you're changing it and people get upset about it. So this is almost the emotional side to budgeting. And that is true. People typically get kind of worked up about it. Frequent demands for budget revisions, very connected to number 1, this one, may result in bias. So because you keep changing the standards, if you like, or changing events, people then feel, if you like, unable to maybe find a focus, and then they get upset if it doesn't favor them. Now, so that's correct. So that takes pretty much 1 and 2 and takes us the answer A. But let's look at the other two. The operational variances. So operational variances are about what actually happened, if you like. That is, operations about tell us actually what happened. That's key. And when I get onto a slide when I'm doing the later questions, I'll come back to this. But remember, technically, we have two types of variances in this sort of area. We have planning variances and operational variances. Planning variances have nothing to do with you. Planning variances are external variances. Planning variances are external factors that have come along and have caused us to revise our initial standard. So we now have a revised standard. And then the operational variance is the difference between what actually happens and the revised standard. And then this is the analysis does not help in standard setting. It does help in standard setting learning processes. That's the whole point of revising it, and we've learned. So 3 and 4 are not correct. So the answers are 1 and 2. Right? So the answer 2 is A. 2 is A. Okay, right. Question 3. So yeah, let's kind of go back into the question and see what. So this is one of those I mentioned in class that are really important to kind of we just go back and to understand the relationship between. Because when you can get asked on learning curves just as a topic on its own, separate topic. But here we're sort of applying the concept of learning curve. It's not a crazy application. It's quite a good application. So look at the question very carefully, saying what is the labor efficiency planning variance, and then what is the labor efficiency operational variance. So they want to do both variances in effect. Let's go back and see the problem. Let's go back and see the problem here. So here's the problem. So our friend over here, and I think I'm almost going to try and literally do it on this screen here. Let's just, if I don't, I'll move on to a spreadsheet. Yes. Oops, sorry. yeah, so our friends over here says that 1 month ago, these people began production of a new product. The standard cost card for one of these units was drawn up at a cost of £84 per labour, based on 7 hours of labour at £12 an hour. So this is quite normal. This is what we do, isn't it? We say, okay, £84 for labour, 7 hours. So we say to make one unit, we need 7 hours. That's what we do. And it says here, therefore, was his actual output during the first month was 460 units. So if I'm asking in a normal variance analysis question, I would say that, well, therefore, my standard amount of hours I would expect in order to make 460 units would be 7 times 460. Let's find my calculator. Would be 7 times 460. So I would sit there and I would say, therefore, in terms of what I would consider my standard, if you like, my standard hours that I expect when you're making 460 units, I will tell you that my standard is 3,220. So that's kind of the first thing to kind of work with. This is the standard. This is the kind of what I'm expecting. Then someone comes along and says to you, oh, by the way, that actually they don't actually spend, they spend 7 hours on the first unit, but they don't spend 7 hours on every other unit, which is the assumption here. So the learning rate comes along and says to us that, well, actually, we can actually tell you how long or how much time we expect to spend on 460 units, given this learning rate of 90%. Because it says that for the first 1,000 units of production, we're expecting learning. So after this, there is no more learning, but we are expecting learning for the first 1,000 units. So you can therefore assume the learning occurred for the 460 units. So the question here is, well, how long did it take how long, based on this learning rate, were we expecting for 460 units? Well, we can find the average first, which is what the learning rate is all about. And if I can find the average, then I can find the total. And how do I find the average? Well, if you remember, we have the lovely little formula of y is equal to ax raised to the power of b, where y was the average, and a was the time it took to produce the first unit, and x was, of course, the units in question, 460, and where b is the learning log, which is log r over log 2, where r is the learning rate time. But they give us this, they give this to us, they tell us that this is in the question. I don't want to go back to it. If you look at it, they tell us that this is minus 0.152. So in effect, I need to find what 7 times 460 raised to the power of 0.152 is. So chuck all this in your calculator, 460, raise it to the power of minus 0.152. So typically on your calculator, look for the yx button. Put in the y, put in the 460 as y, and just, you'll see a little thing, but figure it out. I'm sure your all calculators are different nowadays. That's what's even more confusing about this. So let's do that. 460 raised to the power of minus 0.152 times 7 gives us so y, or when I say y, this y, the average time, mine comes out at 2.75. So it's telling me the average time, if you like, to make a unit, if you like, when you make 460 units, is 2.75. Well, I can find the total time. If the average time is 2.75, the total time therefore must be, well, average times 460. So I'm going to multiply this by 460, and I get 1,267. So in effect, this is my new revised standard. So I started off with this standard. I'm revising it to this thing. So, and I mean, what I'll do is I'll now tell you, sort of say to you, well, what actually happened was you actually took 1,860 hours to make this thing. So this is what actually happened. This is my revised standard, and this was my standard at original. So operational planning variances are telling me that, oh well, you need to change your initial standard from 3,220 to my revised standard, and operational is telling me, well, what's the difference between what actually happened and your revised standard? So let's just quickly do that. So therefore, my planning variance is the difference between this thing and this thing, times, of course, the standard rate. And therefore, we have 3220 minus 1267 times, yes, the standard rate of £12 an hour. And when you do that, when you do 3220 minus 1267 equals that times 12, you get to 23,436. That, and we'll come to the answers in a second. That's my planning. And when I do my operational, I will compare what actually happened to the revised standard, and there we have 1860 minus 1267 times 12, and I have 711. I'm rounding up here. I'm rounding up very badly. This is, keep this in your calculator. You probably have something like 704, 004, something like that. Anyway, right. So let's go to the answers. Again, the problem with this is that every time I come out of this, it forces me to kind of go back to the start. So let me quickly. I'm going to have to roll through quickly, very quickly. Okay, 1 second. I think I can try here. Move quickly. Let's see what if I put 34. Yes, so good. We're there. So good that you can see. So we have. You can see my answers there. So so for my planning variance, that's the answer 23,424, which we calculated, right? And in terms of efficiency, that's my answer 7,104, right? You can see those answers there. Cool, great. Yes, where was I? And then finally, question 5. This is which one of the following statements about the production managers failure to anticipate. So this is another very interesting one. Again, like I guess because this is the last question, so I can sort of do that here as well. If you like, which of the following in him failing to anticipate the learning effect is true? Right. So he's not taken into account the fact that we actually will. Basically, he's budgeted too much. He's budgeted. Coming back to the question, I think it was 7 times 460 instead, which was whatever. Let's just do that very quickly. So in his mind, he's gone 7 times 460. So this is 3220 when he should really have been putting in 1267. So he's budgeted too much, if you like. So because he's failed to not take that into account, this idea there will be unnecessary extra labor costs is false, because actually you've put in additional labor costs, right? That's additional. So that is not true. The selling price, so remember this question tells us, and if you look at the question, it tells us that they base their selling price on a cost plus basis. So first of all, you'd have too much labor cost in there, and therefore when you put your cost plus on that, your selling price would actually be higher. So that's not true as well. So here, let's look at this. Actually, let's go to D first. So it says here the sales manager's bonus would have still been guaranteed, if you like, in spite of the production manager's failure to anticipate the learning effect. It's a bit of a merry-go-round here, because you almost need to kind of go into the factory yourself. You're assuming that it's going to take you 3,220 hours to make 460 units. So in effect, you're giving so much time just to make these 460 units, and in effect, you could really have been making many, many more units with this amount of time. So in effect, you're actually coming out with fewer units than you should. So you have slack, if you like. There are a lot of things, because you've given people 3,220 hours when you should really have given them. You've almost given them literally almost just under triple the time. So it is unlikely that they will be really given that the amount of output will be much less than what we actually expect it to be, and in effect, the sales manager's bonuses, the sales output will be much less than we actually expect it to be for that amount of time, if you like. And also, the classic issue here is that it costs too much. And so the selling price is too high, and therefore you probably won't be able to break into the market because the selling price is too high. So, so in terms from a price situation and a volume situation, we have issues. And again here, this kind of naturally leads on here to this. So an adverse material price variance would probably have arisen, and that's true. So because, in effect, because you have planned for 3,220, but they are actually working faster than that to a certain extent, your balance of stock and raw materials would be very uneven, if you like, because really they're working faster than this, if you like. They don't need this much time. So your planning is just, it's going to be sort of all over the place. And so you might probably have some stock outs. You might have to buy some more stock in a rush because they're suddenly idle, right? Because that's the issue here. They become idle. So chances are that you will have to pay more for stock. So to be fair, this is close to probably your best answer. So the answer is C for this one. But you almost have to kind of work through it and go into the factory yourself. But like all things, this is an exam. So our aim is that sometimes you would probably nail maybe 4 out of 5, and then that's 80%. I mean, that's a great situation. So don't spend too long. You can come back to these type of questions where you have time to literally walk through the process. And of course, it's an exam, so you can go use a process of elimination. But I hope I've been able to convince you anyway as to the thinking process here. So from a pricing point of view, D is out anyway. And so leaving C most likely probably the best answer due to the idle time and the stock outs. Cool, great stuff. See you in the next question.